Today we are going to learn about attitude sensors. When it comes to attitude determination, there are three primary subjects available for reference: the Earth, the Sun, and the stars. This gives us three classes of sensors. All of these sensors work in pretty much the same way as other remote sensing devices. Typically, they are attached to the spacecraft, so the spacecraft must rotate to bring the subject into the sensor field of view. Each of the sensors provides only a 2D reference. To determine attitude in 3D, we often use two or more sensors together. For example, onboard computer can combine data from an Earth sensor with Sun sensor data to get 3D accurate fix. As we will see, all of the sensors can also work in conjunction with a spacecraft ears, which are gyroscope and magnetometer. Along the sun sensor, star sensor, and horizon sensor, or known as Earth sensor, there are another two sensors which are inertial measurement unit, consists of gyroscope and accelerometer and a magnetometer. The sun sensor is most widely used and simple. And why? Because its brightness relative to the other astronomical objects, since the sun is the most brightest object in our system. Also, it's a relatively small apparent radius as viewed by spacecraft near the Earth. The most satellites use solar power, and we must ensure that solar panel oriented correctly with respect to the sun. This is an example of the sun sensor that mounted on the satellite. And sun sensor, also as known, normally used with other sensors as well such as star tracker and gyroscope. Star sensor works by measuring star coordinates in the spacecraft frame and provide attitude information when these observed coordinates are compared with known star direction obtained from a star catalog. This star sensor is most accurate but heavy, expensive, and require more power. This is example of the star scanner. This is the most simplest simplest system of the star scanner because it have no moving part. It consists of a slick configuration, and the spacecraft rotation causes the sensor to scan the celestial sphere. The star image on the focal plane pass a slit and sensed by the detector. This is an example of the gimbal star trackers. Gimbal star trackers operate at a variety of altitude, has a very small optical field of view, which is less than 1 degree, and the electronic assembly causes the gimbal to move so that the star image remains centered in the small field of view. This is the example that you can see from the figure is the gimbal star tracker that mounted on the Hubble telescope. And this is a fixed head star trackers. It uses an electronic scan to search their field of view and acquire stars. It is much more smaller and lighter and have no moving part. It uses an image detector as image definition device. And this is a magnetometer, a device that measures magnetism, the direction, strength, or relative change of a magnetic field at a particular location.
A flex-gate magnetometer works essentially like a compass. But instead of a spinning needle, electromagnets are used to measure magnetic fields. To build one, we start with a bar of ferromagnetic metal. If you wrap a coil of wire around the bar and run an electric current through it, the bar becomes magnetized and generates its own magnetic field. Reverse the current, and the field reverses direction. If you do this over and over again, you can see that the two directions cancel each other out. However, when an external magnetic field is present, the two directions are thrown out of balance, allowing you to measure the external field. Finally, by combining multiple fluxgate sensors, you can measure a magnetic field in 3 dimensions.
This is an example of the magnetometer that normally are mounted on the satellite. And gyroscope are devices that measure the speed at which an object is turning. They are needed to help satellite turn and lock on the new target. Gyroscope maintain orientation and provide stability in both aircraft and spacecraft based on the principle of angular momentum. You can experience this effect by holding a bicycle wheel by its axis and asking someone to spin the wheel. If you try to move the axle of the spinning wheel, you will feel a force opposing your attempt to move it. Gyroscope normally used with accelerometer, and this both unit known as IMU or inertial measurement unit.